Hello everyone, I am Rita Kushwaha working at Velotio Technologies as a data engineer. I have experience of designing and implementing large-scale data pipelines that process streaming data in real time and have a deep understanding of technologies such as Apache Kafka, Apache Flink, and AWS Kinesis. Today I am going to talk about the importance of stream processing and analytics. We will be covering about the problems that require stream processing and analytics as a solution, different stream platforms and frameworks available, and their characteristics and benefits. So without any further ado, let's get started with the problems we face in the real time. Have you ever thought about how real-time market data is available for stock trading and how the risk management is done? What is the best way to promote user interest ads, campaigns to target a particular group of audience? What is the process by which ride-sharing app matches riders and drivers find the most efficient route and adjust pricing based on the real-time demand? How to identify fraudulent activities and detect anomalies in real time so that actions can be taken in real time or immediately to prevent any financial loss to the customer. How media streaming platform identifies which format is suitable for streaming over the internet, what is the best way to recommend content to the users, how to insert ads in media streams in real time. For all these problems, the solution is stream processing and analytics. So what is stream processing and analytics? Before hopping into stream processing and analytics, let's get familiar with the term streaming data. Streaming data refers to a continuous flow of data that is generated in real time, typically from multiple sources. This data could be from social media, IoT devices, and other sources. Stream processing is the process of continuously processing and transforming this data stream in real time. There are two main types of stream processing, stateful and stateless. Stateful processing refers to the ability to maintain state or data across multiple events or data points. This allows the system to remember previous state and use it to make decisions. Stateless processing, on the other hand, refers to the processing of event or data point that does not depend on the state of the previous events or data points. What is streaming analytics? Streaming analytics is the process of taking actions on the data stream at the time the data is generated or published. This could include analyzing data for patterns, detecting anomalies, and making predictions. Now let's talk about batch versus real-time processing. Batch processing refers to the execution of series of jobs or tasks in a batch mode, typically on a schedule or at regular interval, and is well suited for tasks that do not require any immediate results. While real-time processing refers to the process of continuously processing and analyzing data streams in real time as they are generated and enables applications to react to events and make decisions in near real time. Let's talk about batch data processing. This is typically done using extract, transform, load process. The ETL process is used to extract data from its source, such as IoT devices or web application, transform it into a format that can be loaded into the data warehouse. This data warehouse is then used as a foundation for analytical layer, which is where the data is analyzed and insights are generated. A use case can be a credit card company might use batch processing to generate and send monthly bills to its customers. Let's understand real-time stream processing with an example use case of network monitoring system for large enterprises. In this case, data might be generated by network sensors, routers, switches, or security devices. This data will be published to the message brokers. This broker can be Kafka or Kinesis. It is responsible for collecting the data from the data source and forwarding it to the stream processor. This stream processor can be anything, Flink, Spark streaming. It is responsible for filtering, aggregation, transformation of the data. It will analyze the data for security threats and performance issues. The processed data might then be stored in the data sink. This sink can be anything. It can be database, data lake, or time series based database. This database can be used to generate reports or alert administrators for potential threats and monitor network performances. Now let's talk about what is stream processing platforms and tools. These are the software systems that enable the collection, processing, and analysis of real-time data streams. There are several platforms and frameworks available in the market, such as Google Cloud PubSub, Spark Streaming, Apache Flink, AWS Kinesis, etc. Let's first discuss the event streaming platform. We will talk about Apache Kafka, AWS Kinesis, Google Cloud PubSub. Kafka is free open source software that can run on premises or in the cloud. It has the capability of multi-cloud and message retention duration of 7 days by default. The scale can be increased by partitions, and it has a pricing model of free and open source software. The message size default is 1 MB, but it can be increased up to 1 GB. Kinesis is a cloud service offered by Amazon Web Services. It has message retention duration of 24 hours to 365 days. Scale can be increased by increasing the number of shards. The pricing model is based on the data volume and the number of payload units. Kinesis has maximum message size of 1 MB per record. PubSub is also a cloud-based service offered by Google Cloud Platform. It has a message retention duration of 10 minutes to 7 days. Scale can be increased by increasing the number of instances. Pricing model is based on data volume. A PubSub has a maximum message size of 10 MB per messages. We have talked about event streaming platform. Let's get familiar with the three main characteristics of event streaming platform. The first key characteristics of event streaming platform is the ability to publish and subscribe to streams of events. This is similar to the message queue or enterprise messaging system, where data is sent to a queue and then consumed by one or more subscribers. The second key characteristics of event processing platform is that ability to store streams of events in a fault tolerant way. This means that the platform is able to store data even if there is a failures or issues with system. This ensures that data is not lost and can be used for analysis. The third key characteristics of event stream platform is the ability to process streams of events in real time as they occur. This allows immediate analysis and can be crucial in situations where time is the crucial factor. Let's discuss the stream processing framework. We will talk about Spark Streaming and Apache Flink. Spark Streaming is a micro-batch stream processing framework. It supports batch or stream processing and has a SQL support through Spark SQL. It supports multiple languages such as Scala, Java, Python, R, and C#. Optimization is done through manual tuning. It has high latency and configurable memory management. It has fault tolerance and windowing based on time. Spark Streaming uses fault tolerant state backend such as HDFS or S3 to store and manage state. While Apache Flink is a native stream processing framework, it has SQL support through Table API and SQL API. It supports multiple languages such as Java, Scala, Python, and SQL. Optimization is done through auto tuning. It has low latency and high throughput and automatic memory management. It has fault tolerance and support windowing through tumbling, sliding, session, and global windows. State management can be done through in-memory file system and RocksDB. Let's explore the benefit of the stream processing and analytics. The first benefit of real-time data processing is that it keeps you in sync all the time. This allows you to always have the most current and accurate information in time-critical situations. Real-time processing is also quite reactive. This means that it can respond quickly to changes in data or to external events. Another benefit of real-time stream processing is that it is more accurate and timely. This allows you to make more informed decisions and take decisions on the data as it is generated. Real-time processing also involves multitasking. This means that you can process multiple streams of data at the same time, which can be useful in situations where we want to analyze data from multiple sources. Deadlines can also be met with real-time processing. This is because data is processed and analyzed as it is generated, rather than waiting for it to be processed in batches. Lastly, real-time processing works independently. This means that it can process and analyze data without human intervention. This can be especially in situations where you need to process data in large volumes or at high speed. Let's recall what we have discussed till now. We have seen how streaming and analytics can be used to solve real-time problems. We also discussed different streaming platforms and frameworks available in the market and benefits of stream processing and analytics. Thank you for watching, and I hope you find this video informative and useful.